Hey there, Year 12. So in this particular video, we're going to be going through the transition matrices and their applications. Now, this exercise comes in 3 parts, and what we're going to look at is how to model it into a matrix and then how to interpret it. That's the first 2 parts. And the third part will be considered a recursion, what we learned in recurrence and financial modeling. So that's where you'll find the application applied with matrices. So here, let's have a look what we have. They've got this diagram here that you're going to first try to interpret from this diagram. So what is this diagram talking about? Well, we call it in terms of states. Okay, so states meaning saying 2 particular options. And what they're saying here in this scenario is you've got Bendigo and Colac. This is where there are car rental firms. Basically, you can rent a car from Bendigo or you can rent a car from Colac. Now, what the diagram shows is you rent from Bendigo, and this loop over here where it's 80% and it has a loop. What it's trying to say is that if you rented in Bendigo, the chances of you returning it back to Bendigo is 80%. So you can technically rent from Bendigo, but you can also return it in Colac, which in this case is trying to say if you rent it in Bendigo and you return it in Colac, which is shown by the arrow there, it says you got 20% chance of doing so. So they've tried to illustrate that by telling you over here, they're saying that there's 20% chance of cars rented each week in Bendigo, but then returned to Colac. Okay, so that's what the diagram is trying to say there. So the first part is learning how to convey this information in a transition matrix. So how do we start off? When you draw your transition matrix, so we've got our matrix, right? Now the key part is how many states are there? There is Bendigo and there's also Colac. So I know it's going to be Bendigo versus Colac. Okay, so Bendigo and Colac, so it's a 2x2 matrix. Obviously, if you have more of these states, then that will change it to a 3x3 or a 4x4. And so in this particular case here, we always say the initial event, okay, anything that starts off in the problem always goes up here first, and then on the side is always second. Okay, so what I'm trying to say there is that you rent the car from Bendigo or Colac, and you then return is always over here. So first is always on the top, and then return is always on the second. So if I basically looked at the diagram and tried to write it in a matrix, if I rented from Bendigo first, the chances of me returning it back to Bendigo is 80%. So if I rented in Bendigo and then I need to return it back to Bendigo, well then the chances are 0.8 or 80%. Okay, now we can see again looking at Bendigo, if I rented in Bendigo, the chances of me returning it to Colac is 20%. Another thing to note here is that Bendigo returned in Colac. If you add 0.8 and 0.2, notice this gives you 100%, because those are the only options you had, wasn't it? You rented from Bendigo, you either return it to Bendigo or you return it to Colac, or technically you could steal it and just never return it. But that's not the current scenario. You only got 2 scenarios there. Chances of you returning it to Bendigo is 80%, and then obviously the remaining percent, which is 20%, that goes to Colac. All right, and so if I fill out the Colac version, hopefully you're able now to see if I rented from Colac first, the chances of returning back to Colac is 90% based on the diagram, so it's 0.9. And obviously just from that concept, I know this must be then 0.1, because I know vertically it has to give me 100% of the options that I can do once I rent from Colac, right? But if I look at the diagram, you can also see renting from Colac and returning it to Bendigo is 10%, which is 0.1. Okay, so that's the idea. That's the first part of this exercise that you need to be able to do. So let's have a look at this diagram over here. Let's see if we can do the same now. Okay, so setting up a transition matrix. Sorry, my nose is very very blocked right now. All right, so the diagram shows the weekly return rates of rental cars at 3 locations. You've got Albury, Wodonga, and Benalla. So these are your 3. That means I've got a 3 by 3 matrix because it's 3 states. So Albury, Benalla, and Wodonga, A, B, and W, right? And remember, in this case, what am I doing? It's rental cars as well. Okay, so it looks like I'm renting and then I'm returning. Is that right? Describes weekly return. Okay, cool. So it is. So return is going to be over here. So let's look at the diagram. It looks like if I rented from A and then I'm returning it back to A, that's 70%. So renting from A and then returning it back to A is 0.7. And then I can say renting from A, but returning it to W is clearly 10% there, so 0.1. So renting from A and then returning it to W, we can see, whoops, I just rubbed out the A there. And then I don't really need to look at the diagram, but I now know that this has to be 0.2. Because remember, this, if I add them vertically, they should all add up to 1. 0.2 plus 0.7 is 0.9, 0.9 plus 1.1 is 100%. But let's look at the diagram anyway, and we can see that from Albury going to Benalla, so renting from A, returning at B, you can see it's 20% here, so that makes sense, it's 0.2. Okay, so following that diagram, we can try to fill in all the other points now, so starting from W, so right here, and I am going to return it back, return it back to Wodonga, so W to W is 0.8, W to B, so renting from W and then returning at B is 0.15, so 15%. So obviously the remaining has to be then be 5%, which is, where's the diagram? Whoops. We can see the diagram going from W to A is 5% right there. Okay, so 0.05. And then same thing with B. If you're wondering how I'm changing it to percentages as well, I simply did 5% means divide 100, and that's how I got 0.05. I just realized that as well. Okay, so just to make sure that you know how to change them to decimals. And then similarly, I'm now going to do B. So from B, if I'm returning it to W, that is 11% there. So B returning to W is 0.11. And then B returning to itself is 0.77. And then finally, B returning to A, which is down here, 0.12. Okay, so that's how I would answer this question here. Convert the percentages to proportions, and this would be considered a proportion. Okay, there we go. And technically, you can also write it as a fraction if you prefer, but decimals is also a proportion. Okay, there we go. So that's how you do example 8 of this exercise here. And similarly, you'll be doing the same in example 9. So let's have a look here. Setting up a transition matrix. The factory has a large number of machines. Machines can be in one of 2 states. So we already know it's a 2 by 2 because it says 2 states. What's the 2 states? Operating or broken. So it's operating or it's broken, operating or it's broken. And then it says broken machines are repaired and come back in operation, and vice versa. On a given day, 85% of machines that are operational stay operational. So it seems like, were they operational to begin with? Okay, so if they're operational, then they stay. So they stay operational is 0.85. And obviously then that tells me the leftover has to be 0.15 because it has to add up to 1. True? So if it was operational to start off with, but then it stays broken later, well then there's 15% chance there. But you can also read it here, 15% of machines that are operating break down. Okay? And then you go to the next one, 5% of machines that are broken are repaired and start operating again. So it was broken to start off with, and then it starts operating later because it's repaired, was 5%, so 0.05 there. And then finally, 95% of machines that were broken stay broken. Well, that's 0.95 there. Okay, construct a transition matrix. This is called a transition matrix. So T, you can, and it's called a transition matrix. I didn't start off with that before, but essentially it's talking about the movement between machines to machines. So from operating to broken, or from Benalla to Wodonga, it's movement, and the matrix talks about or describes a transition between the states. Okay, so that's why we call that transition matrix. To describe a situation, use the columns to define the situation at the start. So whoops, I should have called it the start, and then maybe the other one is the end of the day. So this is end of the day. Okay, and that's about it. So that's how you do the first part in understanding how to construct a transition matrix. Okay, which is for this exercise over here. Okay, very small, short one.